So everybody take a picture of this. On tonight's homework, that's due tomorrow. If you're like, I don't remember what to do, those are the instructions of how you bake a momentum cake. Conservation of momentum cake. Okay? Now, example 2. Big 5-kilogram fish is swimming at 2 meters a second, 6 meters a second westward towards an absent-minded smaller 2-kilogram fish swimming at 3 meters a second eastward. When the 5-kilogram fish swallows the 2-kilogram fish, what is the 5 kilograms fish's velocity immediately after? Okay. So first thing, let's just throw this out. Dory would not have made it to adulthood. Like, she definitely would have been gobbled up real soon. So throwing that out there. Now, the next thing we got to do is we need to pick the direction you want to be positive. Okay? If I were in your shoes, I would pick west to be the positive direction. However, for an educational opportunity, I'm going to pick east to be positive. Okay? It's not going to be wrong. Okay. I'm going to pick to the east to be positive. Looking at this, I'm trying to discern what objects would I stick in my system, what objects would I include in my system, so the total momentum of the system is conserved. Two objects interacting are the big fish and the small fish, so that's what I'm going to include. And I'm looking at saying, yep, total momentum is conserved. So total momentum final or initial is equal to total momentum final. That's kind of mathematical way to say momentum is conserved. For this specific scenario, I've got the momentum of the big fish plus the momentum of Dory initial. That would be the momentum of the system. I'm looking at all the objects in the system, adding up their individual momentums. That's the total momentum of the system initially. And the total momentum of the system afterwards is the big fish plus Dory after. Now, remember that momentum is equal to mass times velocity. So to find the momentum of the big fish, I'm going to go mass times velocity. Because velocity has direction, and I've been given a value, I need to assign a positive or negative sign to that. And in this case, it's going westward. I've said west is negative, so I need to include that. Okay, this right here is the number one reason why you're going to miss problems on the test. Right here. not including the directions for momentum or velocity. The number one reason. The math in this chapter is not difficult. What gets people is they forget to do the direction. Okay. So your final is going to be all multiple choice. One of the answers is going to have this negative. Another answer, another choice, is going to have this without the negative. So you're like, hey, I got something on my calculator. Matches the answer. Doesn't mean you got it right. Okay. So please watch that. So going westward, going eastward. Okay. Afterwards, big fish has some unknown final velocity. Dory So from your perspective, from your vantage point, from your camera angle, from your frame of reference, after Dory gets swallowed, is she moving? Just keep swimming, swimming. Is she moving relative to your position after she gets swallowed? If you said no, here's what it would look like. Just keep swimming. So either the big fish has an extraordinary digestive tract, or we just blew out the tail of the big fish. Because the dory is in the big fish's stomach. Is the big fish moving relative to you after it swallows Dory? Yes. Therefore, Dory is as well. Does that make sense? From your point of view. Okay. So you could either say that Dory has the same velocity as the big fish afterwards, or you can say that the big fish is now 2 kilograms more massive because it has a full stomach. Either way is fine. Does that make sense? So I'm doing some math here. Find our answer to be negative 3.93 meters a second. Now, on the exam, here are your choices. A, 3.93 meters per second eastward. 3.93 meters per second west. And then you'll have C and D of not including the -6, east to west. That's what your test is going to look like. Okay, for conservation of momentum questions. Okay, so it's not going to say -3.93 because you might have picked the east or west to be positive. So you need to decipher this. Is this going in the east or west direction? Based upon how we defined it, it's going west. That makes sense? Okay. So recap: for velocity or momentum, you must assign a positive or negative value to it. If you are solving for velocity or momentum, that's like your variable, your unknown, do not assign a positive or negative to it. And that positive or negative sign, the direction of that, will come out in the answer. Good with that? Any questions there? Okay. All right, back to the football players. Talk to your neighbor.
It's more like a concept than velocity. They sound. They have the same times. Well, if they stick together, they're gonna have very close. Yeah. They should.
I should wait, but that's like. Wait. Like they're just like there. Like you can still go back and
But they'll have the same velocity.
do you want to? You didn't even try
Okay, correct answer is? Correct answer is C. They're stuck together. Everybody go with that? Okay, same scenario, different question. C, both have the same. They're stuck together. Okay, this question is asking individually as two football players moving together, which one's going to have a greater momentum after they collide? Which individual football player is going to have a greater momentum after they collide. Talk to your neighbor.
Oh, wait. Shoot, I looked front.
I was like, it kind of sounds like you have their side of the argument.
They have the same velocity.
So it can't be true. Okay, there's these because that's what they said on the last one. We don't know the
No,
math.
they have the same velocity, but we don't know the math.
Wait, why do they? Oh, they do.
But then
Oh.
the one on the right looks a little bigger.
Yeah, it's
Correct answer is? Correct answer is D. What are you missing? Mass. Okay? They have the same velocity afterwards. So the one that has more mass is going to have a greater momentum. Is it possible for the Raider to be more massive, to be less massive than the Maverick? It is possible. Possibly more massive? Yep. So you don't know. Get with that? Okay. I've now updated the question. You now know mass. Talk to your neighbor. Tell your neighbor. Everybody good with A? 200 divided by 80 is greater than 140 divided by 100. Good with that? Last question in the series of football players. So again, I'm looking at them as two individual players, not one conglomerate. Correct answer is? Correct answer is B. Why? They both have the same velocity. The Maverick has more mass than the Raider. Okay? Good with that? Okay. All right. So that concludes our lesson for today. Okay. Before you go print,